This is an introduction to optional types in Swift. As a reference in this video, I'm going to be using Apple's book, The Swift Programming Language. In it is a language guide with a section called The Basics, and in the Basics is a subsection called Optionals. And I'll be using this along with a project that I'm going to create, which is a macOS command line tool. I'm going to call this Swift Optionals 1. And I'm going to save this in Documents, Projects, macOS, a folder I created for my macOS projects. And a main.swift is automatically created, and this is where I'm going to put my code. Main.swift is the starting point for a command line application. And I'm going to delete this line, print hello world. The book, The Swift Programming Language, has information on optionals, and you should read this. But really to understand how this works, you need to be writing code and experimenting with the code. So this project I'm creating is here to show you how to experiment with the code and also demonstrate how optionals work. Before I work with optionals, I want to declare a variable that does not use optionals. We're going to declare a variable called name, and it's going to hold a type string, and I'm going to initialize it to my name, which is Dale. So var means it's a variable. That means this thing can change. It can be assigned to Dale now, and it can be assigned to something else later. The colon string is the way that we declare the type. And so the type here is a string, and then it's being initialized to an actual string, which is Dale. And if I use my option key and hold it down and get the exclamation point and click on name, we see that in fact it is a string. And even if I remove the colon string, it's implicitly going to be a string because it is initialized with the value Dale, which is a string. I'm going to put that string back. Doesn't hurt anything. And now we have a variable called name that is a string, and it has been initialized to hold Dale. What if at some point in my code I don't want the name to hold an actual string, a name? What if I want it to hold nothingness? I want to imply that there is no value, or I want to state that there is no value. How do I do that? Well, in Swift, we have the nil keyword, and as it says in this documentation, you can set an optional variable to a valueless state by assigning it to the special value nil. Well, let's try and use nil. I'm going to say name equals nil. So what I'm trying to say here is that the variable name is being set to having no value at all, to being a valueless state. And Xcode doesn't like that. It says nil cannot be assigned to type string. Well, and if we look at the documentation again, it says you can set an optional variable to a valueless state. And string is not an optional type. String is the type string. So the question is, how do we create a type that's an optional type? A type that can hold either a value like Dale or no value at all, which would be nil. There are two ways to do this, and the first way, probably the most common, is to use a question mark after the type. So now we don't have a string type, we have a string optional type. In fact, if I hold down the option key on the keyboard, get my question mark and click on this, we see the declaration says var name string question mark. And that is read, understood as a string optional. What it means for us to have a string optional is that we can have a variable that can hold a value like Dale, or it can have no value at all, like being set equal to nil. Only optionals in Swift can be set to a valueless state, that is, be assigned nil. Without the question mark, this is a string type, not a string optional type, and I'm not allowed to set name to nil. So let's say we do have a string optional type, and we are setting it initially to Dale, and I want to then set it to nil. I'm allowed to do that. There's no complaints about it. But let's say we want to work with this name. How do I know whether I have a nil or not? How do I determine whether I have a value? Well, if I were to think of this in kind of traditional terms of other languages, I could just do a test. I could say, if name not equal to nil, then let's do something. And keep in mind, in other programming languages, instead of nil, they might use a word like null. So if name is not equal to nil, then I can do something with it. So let's say if it's not equal to nil, I want to print it. So I'm going to say print name. Seems like a reasonable thing to do. I might also say else print name is nil and has no value. So let's run it, see what happens. And we get here name is nil and it has no value, and that's because if the name is nil, name not equal to nil is not going to happen, so the else condition happens and this print occurs. Notice here, though, we got expression implicitly coerced from string optional to any. Kind of ignore that for a moment, because it's having some problems here with name, and there's a good reason for that that's going to show up here in a second. Name is not a string, it's a string optional. And what print wants is a string. It wants to print out strings. So it's saying, hey, I don't really know what to do with this string optional, so I'm going to convert it to, coerce it to this type which is called any, which we'll talk about later. But in short, any is a way of referring to any type. So all types, if I have a variable declared as type any, can be assigned to that variable. Let's say for a moment name is not set to nil. So we have here our name is a string optional and it's being set to Dale. And we're doing the same test. If name not equal to nil, and now it's not equal to nil, we try to print it. So when I run this, we're still going to get that statement. That's fine. But look at the output that we get here. Instead of printing Dale, it printed optional parentheses Dale. And that's because name is not a string, it's a string optional. A way to think about an optional is like a box. The box always exists. We're always sure that we have the box. So string optional here is like the box, and the actual box, name, the thing, so let's write the word name on the outside of the box. Name will always exist because it's a string optional. So the variable name, being a string optional, will always be there. We don't have to worry when we go to use it that it is or isn't there. It's always there. But in the box, we may have, as we do here, the string Dale, or the box may be empty. It may have been set to nil. So name alone isn't a string, it's a string optional. And so when I go to print it, I am being told, well, what you have here is an optional that contains Dale. So the question that we have if we're working with optionals is, how do we get the value out of the optional? How do we retrieve it? And if it contains no value and we go, try to retrieve it out of the box, we would end up with nothing. And if it has a value, we want to retrieve that value. Well, one way to do that, because here we already know that name is not equal to nil, we can force unwrap the name. And this is covered here in the if statements and forced unwrapping. If we're sure that we have something in this box, which is name. If we're sure we have something in the optional, we can force unwrap it using the exclamation point. Name exclamation point is saying take the optional and force unwrap it, pulling the value out of it. Now you would only want to force unwrap if you're sure there is something in the optional. If there's nothing in the optional and you force unwrap it, we're going to end up with a problem. But just to show that this works, remember that when we didn't have the exclamation point and we printed name, which was a string optional, we got optional Dale in the printout. But now we're putting an exclamation point, which is a forced unwrapping. As we say, this is known as forced unwrapping of the optional's value. So if you force unwrap it, we're pulling the value out. And because name is not equal to nil, we know that we can do that. So if I run this, instead of getting optional Dale, I get Dale. So that forced unwrapping worked. Now let's say for a moment, I'm going to delete this. We didn't have the test to see whether or not that name was equal to nil. So let's just say we said print name exclamation point. And the code as currently written isn't going to cause me a problem because I declared a variable name that is a string optional and I initialized it to Dale. So when I say name exclamation point, it's going to unwrap it, pull the Dale out, and that's what's going to be passed as string and printed. So when I run this, we are indeed going to get Dale. But let's say in our code, at some point, name got set to nil. That is, we are indicating that, going back to the documentation, that it is a valueless state. It has no value, so name has no value. If I try to force unwrap it, there is no value to pull out of it. What will happen if I force unwrap name while name is set to no value, is set to nil? So I'm going to compile and run the application, and boom, we get a crash. We get a bad execution because we are passing nil to print, and that's not a string, and it doesn't know what to do with that. We know we can unwrap with an exclamation point. This is forced unwrapping, but this is unsafe unless you are very sure that there is a value in name when you force unwrap it. And right now there is no value. It's nil. So is there another way to get the value out of the optional so that we can do this safely? And the answer is yes. We can do something called optional binding. I can say if let name equal name, print name, else print name is nil and has no value. Let's see how this works. I'm going to stop my current execution and build and compile and execute this. And we get name is nil and has no value. If I comment out name equal nil, so that name is set to Dale, and I run this, I see that I get name, not optional name, I get name. So what exactly is happening here? This if let, this thing that is allowing us to do this optional binding, takes name, which is an optional, and looks to see if it has a value in it. So this is kind of the if part of this. It says, if there's something in name, if it has a value, then it's going to take the value out of name and assign it to name. Interesting. I made it exactly the same variable name, but it's not the same. This is let name, and what this is saying is that name here is a constant that the value out of name is going to be assigned to. So the if says, can we take what's in name, pull it out, the value, and assign it to a constant name, and then that constant name is going to be available inside this if statement. So assuming we can unwrap name, take the value out of name and put it in name, the unwrapped version, then inside the if let, we are able to use name in its unwrapped state. If, on the other hand, we're not able to pull a value out of name and assign it to name, then the else condition is going to happen, and we're going to say that name is nil and has no value. So why can these be the same name? Well, they don't have to be the same name. First, I could, for example, say if let unwrapped name equal name, and then inside here I would want to print unwrapped name. And let's run this to see that it works. We get Dale. So the name here on the right is the optional, and again, it's just like I said, if this is an optional, it has a value, this if let is going to take the value out of it and assign it to the thing on the left side of the equal sign, in this case unwrapped name. So inside the if let, unwrapped name is not a string optional, it's a string, and I'm able to print it. And in fact, for a while in the history of Swift, this is sort of what you had to do. You would have an existing variable called name, and you would say, okay, I need to unwrap that in this optional binding, and so I'm going to create another thing that's a constant of a different name, so that when the value is pulled out of it, it is assigned to this constant. And I know I did this, and I saw a lot of code that did this. You had to come up with another name for this, and so you might have said something like unwrapped name equal name. And that's not particularly convenient. If you've done a lot of programming, you know that you spend a lot of time coming up with good names for your constants and variables, and now having to come up with a new name for the unwrapped version of the name that you have is pretty difficult to do. So in the history of Swift, Apple moved from requiring this to be differently named to being the same name. So when I do this, it's allowing me to reuse this well thought out name that I came up with and have it in the scope of the if let take on a different meaning. So I'm going to say this one more time. The if let name equal name takes this name, the one on the right, which is a string optional, and checks to see if it contains a value. If the optional contains a value, then it's going to assign it to the constant name, and that constant name is going to be a string, not a string optional. So it's going to be the unwrapped version of the string optional inside this if let, and I'm then able to use it and be sure that it's not nil, and have it in an unwrapped state. So as is written, if I make name equal nil again and run this, the else condition is going to happen, and we're going to print out name is nil, it has no value. So again, this is optional binding, and it allows us to take an optional and pull a value out of it if it exists and assign it to a constant. And if it can't do that, it's going to fail and do the else condition. Another way to create an optional is to use the exclamation point after the type. And this is an implicitly unwrapped optional. So this is an optional like we looked at before. It has the same properties. It's a box that can either hold a value or indicate that there is a nil. But when we go to use it, we don't need to unwrap it. It will implicitly be unwrapped when we want to use it. So I'm going to delete these lines, come out the name equal nil for a moment, and illustrate this. So I'm going to say here, print name. And I'm going to run this. And we see we get Dale. We don't get optional Dale, we get Dale. I'm going to put this back to a question mark and run this again. and we get the optional Dale. But if this is string exclamation point, and we run this, we get Dale. Now, this is still a string optional, but it's an implicitly unwrapped optional. And what this means is that when we go to use name, like when I say print name, and there's a value desired, it's going to automatically do the unwrapping and at the point of use give me the value. So I don't have to explicitly unwrap it. Now this, like the forced unwrapping we looked at a little earlier, can be actually dangerous, because I could say that name is initially set to Dale, and then I could some point later in my code set name equal to nil. And when I go to run this, name inside the print is going to be implicitly unwrapped, and I'm going to have nil there. And if I am intending that name is going to be something other than nil, that won't always be the case. To kind of illustrate, because this isn't crashing, because print knows how to handle this implicitly unwrapped situation probably better than it should. I could do the following. Let's say I create another variable called greeting, and I could say hello space concatenated with name, and then I'm going to print the greeting. So let's run this and see what happens. Boom, we have a crash. Why? Because I am creating a new variable called greeting that is a concatenation of a string, hello space, with name. The problem is this optional, which is an implicitly unwrapped optional, has been set to nil. When I go to use name here, I am implicitly unwrapping name. This is nil, and it's not a string, and it can't be concatenated to a string to create a string, and this is causing the program to crash. And we can see here, fatal error, unexpectedly found nil while unwrapping an optional value. So implicitly unwrapped optionals can be unsafe. There are times when they might be useful, but if you use them without consideration that they will implicitly unwrap, and it's possible because they're optionals they could be set to nil, you could run into some trouble. On the other hand, if we use string question mark and try to do the same thing, we have a different problem, and it says value of optional type string optional not unwrapped. Did you mean to use question mark or exclamation point or question mark? And the thing is, if I were to say take name and explicitly unwrap it, so force unwrap it, this is also going to crash, because unwrapping name is going to give me a nil, and I can't concatenate that to the string. So if I am going to use a normal string optional and want to do this concatenation operation, then I'm going to have to safely unwrap this and print the greeting. So how could I do that? Well, we learned here a second ago about optional binding. So I could say if let name equal name, that is, if we can unwrap the name, then we could create this greeting, and we could print that greeting. And we will be fine, except that we don't want to or need to do this forced unwrapping that we see here, because if let name equal name unwraps what's in name into the constant name, and then that unwrapped version is available here. So we don't want to unwrap something that isn't an optional. So name here is name here, so it's the unwrapped version. So if I say var greeting equals hello concatenated with the name and print greeting, this will only happen if name can be unwrapped. And currently name is nil, so this if let statement set of statements is not going to execute. And I can show that by having an else and say print I have no one to greet. So let's run this. And if I comment out the name equal nil so that name is set to Dale and run this again, we get hello Dale. Because Dale could be unwrapped, that leaves us inside this if let, so then I can create the greeting and print it. Otherwise, I choose not to. The use of optionals in Swift forces me to consider that situation where a variable may have no value. In other languages, you have to consider that, but the language really doesn't force you to consider it. When you write code in Swift, you're creating optionals in situations where the variable may have no value, and then when you use that variable throughout your code, you always have to consider the possibility that that variable has no value and do things like we do here with the unwrapping of name before that we use it. So the implicitly unwrapped optional with the exclamation point can in fact be treated like an optional that was created with a question mark. So even if an optional is defined to be implicitly unwrapped, that is using the exclamation point, we can treat it like any other optional. So if we want to test to see that it has a value and unwrap it just like we do with an optional with a question mark, we can do that. So here's my implicitly unwrapped optional, and I have my if let name equal name like I used with the normal string optional. This code will execute just fine. So I can have an implicitly unwrapped optional but not rely on it being implicitly unwrapped. I can actually do the unwrapping and use it just like any other optional. So except for the fact that an implicitly unwrapped optional will automatically unwrap itself when it's used, it is the same as a normal optional. So implicitly unwrapped optionals are kind of a convenience, but remember that they can in fact create problems if you don't test them before you allow them to be unwrapped. So we've covered optional binding, that's the if let. We have the forced unwrapping. Remember, that's when we use the exclamation point to cause it to be unwrapped. But remember that you don't want to force unwrap something and use it in a place where you might have a nil. Nil is used to declare that a variable is set to a valueless state, that it has no value. And optionals are the way that we basically take a variable and indicate that it can be set to nil.